Hi, my name is Rebecca Weaver. We're going to be covering section 4.2 today, the exponential function e to the x. We're going to be reviewing this function. So the number e, this is a naturally occurring number. It's an irrational number, approximately equal to 2.718281828. It continues on without a discernible pattern, although it looks like it has one here. It doesn't. Such that the function f of x equals b to the x has a slope of 1 at x equals 0 when b equals e. And the example of this is f of x equals e to the x. Now, the derivative of 2 raised to the x, we're just going to give that to you without proof. The derivative of 2 raised to the x is m2 raised to the x, where m is the derivative of 2 to the x, where x is 0 equals 0.693. So if we want to know the derivative of y equals any base raised to the x, that's just going to be m times b raised to the x, where m is the derivative of b to the x at x equals 0. So let's figure out what in the world this means. So we have the derivative of 2 to the x, where x equals negative 2. Okay, so I'm just going to write down what we have here with our definition, and we'll see that m times 2 raised to the negative 2, and this is approximately equal to 0.693 times 0.25, because that's 2 raised to the negative 2, and we get that it equals 0.173. So writing these down again, the derivative of b raised to the x equals m times b raised to the x, where m is the derivative of b raised to the x, where x equals 0. Looking at that and comparing that with my y equals e to the x, notice that we talked about that e to the x, that slope was 1 at x equals 0. So the derivative of e to the x is just e to the x. Well, that is a relief, because most of the time you're going to be dealing with these e to the x's, and that's what we're going to be looking at, so that makes it really sweet. So let's look at an equation where we're to find the tangent line to the curve y equals e to the x over x plus e to the x at 0, 1. Now for our solution, we must first find the derivative function and then find the value of the derivative at 0, 1. Okay, so we're going to find that derivative, and then we're going to find the value at, so we're going to, that value of the derivative at 0, 1, that'll get us for our slope. Then we can use the point slope form of a line to find the desired tangent line equation. So that'll be a little bit later. So first let's write down our equation. All right, there's our equation. We're going to take the derivative. So the derivative of e to the x over x plus e to the x, we're going to have to use our quotient rule. So here, using our quotient rule, where we write down the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared, and simplify that bad boy. So here he is. We're just going to do some simplifying, multiplying, factoring out, combining like terms. We're going to end up with e to the x times x minus 1 all over x plus e to the x, the quantity squared. Now we're going to evaluate the derivative at x equals 0, so plug in a 0 for x. And we're going to, once we do that computation, we're going to get that that derivative equals negative 1 at that point. So that's our slope. So now we know a point on the tangent line 0, 1, and the slope of that line is negative 1. Now we're just going to use the point slope form of a line to determine the equation of the desired tangent line. So here's our point slope form of a line. Plugging in our point and our slope, and then simplifying, we'll get y equals negative x plus 1. All right. You're going to be doing a few of these like this. So if you need any help, be sure and email me. And my email is rweaver10@alaska.edu. Have a wonderful day.